Next, let's solve an equation with radicals that contains two radicals. For example, I have the square root of 3x plus 1 plus the square root of 3x equals 2. To start this equation, I need to isolate one of the radicals. Doesn't matter which one. So I'm going to go ahead and subtract the square root of 3x from both sides of my equation and get just the one on the left alone. Now I have the square root of 3x plus 1 equaling 2 minus the square root of 3x. So again, first step, isolate one of the radicals. Second step, undo the square root. So we're going to square both sides of the equation. So on the left-hand side, I have the square root of something squared. They undo each other. I'm left with just 3x plus 1. The right-hand side gets a little bit more complicated. It's a quantity times itself. Again, you need to box or FOIL that out. So I'm going to go ahead and use the box here. 2 minus the square root of 3x and times itself, so 2 minus the square root of 3x. I'm squaring that whole quantity. First box, 2 times 2 is 4. Second box, 2 times the negative square root of 3x is negative 2 square root 3x. Same thing bottom left corner. 2 times negative square root of 3x is negative 2 square root 3x. Last box, negative square root of 3x times negative square root of 3x. A negative times a negative will make a positive. And then we'll have the square root of 9x squared. 3 times 3, x times x. Then I'm going to go ahead and simplify. Rewrite the whole thing out just so you can see it kind of expanded. And then plus, I'm going to go ahead and take the square root of this last box. So square root of 9 is 3. Square root of x squared is x. And I have some like terms. So I have 4 minus 4 square root of 3x. Right? Negative 2 and a negative 2 make negative 4. And then plus 3x with no radical. Alright, that's what I'm going to write up here. 4 minus 4 times the square root of 3x plus 3x. Now, from there, that's my side work, I still have a radical. And you say, wait a minute, I thought I got rid of my radicals. No, there were 2. So we got rid of one of them. Now we have to get rid of the other one. So I need to isolate that radical now. I'm going to subtract 4 from both sides. Subtract 3x from both sides. When I do that, I have 0 here. 3x minus 3x is 0 there. 4 minus 4 is 0. And I'm left with 1 minus 4, is negative 3, equals negative 4 times the square root of 3x. Okay, from there, I notice that I still have this negative on both sides. So I'm going to go ahead and just get rid of that negative by dividing both sides by negative 1. And a negative divided by negative makes a positive. Now, there's one last thing that you could do before you get rid of that square root. You could divide by 4. And that's going to give you a fraction. You have to square that fraction. It's going to be a little bit messy, which at some point we will have to deal with. But because this is a product here, and I'm squaring both sides of the equation, it's not actually going to affect my final solution if I left that 4 there. If it was 4 plus the square root, that's different. But because it's multiplication, I can just go ahead and square both sides of the equation. I just have to make sure I square everything. So 3 times 3 is 9. 4 times 4 is 16. Times, this was times here, still times, the square root of 3x squared. So I'm squaring it, I'm unsquaring it, I'm left with just 3x. Now from there, I can go ahead and multiply. 16 times 3 gives me 48x. Divide both sides by 48. And then simplify my fraction, reduce it to the lowest terms. So this has a common factor of 3. I divide out a 3 from the numerator and denominator, and I'm left with 3/16 equals x. And I have checked it, and it does work. Again, don't forget to check your solutions.